Hi, everyone. Thanks for tuning into the Printed Circuit podcast, where we discuss trends, challenges, and opportunities across the printed circuit industry. I'm your host, Steph Chavez. In this episode, we'll focus on education. Here to join me is Tim, CEO of Timberwolf. Thanks for being here, Tim.
Thanks for having me.
Could you give our audience a summary of your background and experience and what you bring to the table and the whole magic that you bring? Because, after initially talking with you, man, oh man, let's share that.
I started in the Marine Corps back in 04 to 08. Got 2 deployments out of that one. I've deployed as an ISR pilot captain to multiple theaters, Afghanistan, in support of Special Operations Task Force. I've used a lot of defense electronics and avionics and equipment throughout my time. So I have a personal investment in it because I've used it, and the quality of the hardware that we use has real implications out there. I kind of got into electronics. My dad actually did a lot of printed circuit design. He's rather talented, and he pushed me to make some transitions. No longer flying at the moment. I will go back to flying eventually, but now I'm full-time electronics, focusing on printed circuit design.
From one Marine to another, man, thank you for your service, brother. Yellow footprints, man. Stand on those yellow footprints. So with that said, Tim, tell us about the current projects and challenges you're seeing, especially in regards to the skills gap. Engineers with needing the vital education, especially when we talk about specific knowledge domains such as power integrity, EMC, and basic the foundation when we think about board stack-ups and routing and the essence of the purity of designing a circuit board.
Most everything that I work on is defense related, so I can't get into detail on everything, but a lot of radio equipment, a lot of mixed signal. We're getting into high speed. I have not done a board in the last 2 years that didn't have at least 10 gigabit on the board. I'm starting to see even the experienced guys, which we're running short of, they're retiring, and there's nobody to replace them. That's one of the major issues, and we need to keep these skill sets alive in this country moving forward. It is a national defense issue. It's a sovereignty issue. We need to be able to rely on ourselves for everything. One of the things that I've found is that some of the older guys they've got a foot out the door, and some of the techniques and what we need to do to be able to implement 25 and 52 gigabit on a board reliably. My last design had 64 25 gigabit lines on it, and the board was very small. You're trying to make all this stuff work. Had DDR4 on it, and it was extremely, extremely dense. We're getting into things people haven't done before, and a lot of people I'm seeing in the industry are struggling with implementing these things. So not only are we losing some of the legacy ability and legacy experience that's out there, we're also moving into things that are brand new that people haven't done before, haven't seen before. So what I'm seeing right now is that there's a gap. There's not a lot of investment out there in some of the younger people. With that lack of investment, I'm trying to fill the gap. And I'm specifically trying to fill the gap for defense applications so that we have everything that we need to move forward, that when there's a call for something, we can deliver it and it'll work the first time, and it's reliable for our guys on the ground to be able to say, my life depends on this equipment. It's going to work.
It has to. I mean, when you think about, especially mil-aero, you think about class 3 designs, tight tolerances, high quality, you got to deliver. And it starts at the essence of engineering. Got to know what you're designing, how to implement the designs according to that class or to meet your needs regarding the envelope of what you're designing. Is it in the avionic bay of the aircraft? Is it out on the wing? What is its environment? And these are a lot of details that go into what it takes to bring your widget to the market. You've got to understand. And then, like you said, we're pushing the envelope, especially as things are getting smaller, tightly compacted. You mentioned the 25 gigahertz, you talk about DDR4. The complexity is only going up. It's getting more and more, especially because it's getting condensed, smaller and smaller. Education and mentorship, these all come into play, or the lack of it is really affecting our industry, especially when you think about engineering jobs. 1 out of 3 engineering jobs are going unfilled, in the industry, and it's getting worse, when you think about that skills gap. At what point, Tim, did you get involved with education in the next generation of the PCB engineers? Was there a specific trigger, or what sparked it?
There's a couple things. I've been in education for a long time, as every pilot does. I went through my phase as a flight instructor. When I was in the Marine Corps, my primary MOS was nuclear, biological, and chemical weapons. So that's 80% of that is instructing. So I kind of recognized the shortfalls with academia. The curriculum is really lacking what is necessary. There's a lot of time spent on things that are not relevant to the modern world, rather than just hitting on a concept, moving on, and then getting into application. There's a lot of emphasis on theory, maybe just to appease an ABET requirement, and that's it, versus saying this is what you need to go out and do something. So I'm recognizing that academia is missing application of tools. There is some exposure to certain tools, but they're not the tools that we really need to do some of these high-end designs. That's one of my major issues. I might be a little snobby, but I really lean on Xpedition for everything I do. I can't see doing any of the designs that I do in any other tool. It's just not something that I see as feasible at the moment. Maybe someday they'll progress, but as of right now, Xpedition is what I'm using. And I don't see that changing anytime soon. But there's no exposure, there's no avenue currently to expose students, engineering students, to some of these tools. What I'm noticing right now is that some of the gap between the real world means that a lot of these guys have to go spend their first 2 years on the job learning tools, learning how to actually apply these things. That gap is a major issue. I'd like to see academia. It's going to take some investment. I think that's one of the big things, is that there's been a lack of investment. It's going to take government funds investment. It's going to take major corporations investing to be able to fix some of this. But right now I'm seeing a cliff, and going forward, as these guys retire, and most of them will be retiring soon. I'm the youngest by 20 years, where I'm at primarily. It's going to be a major issue, because as soon as they retire, even the basics can't even be done. Another thing that I'm seeing, there's no entry level to this industry anymore. You can't grow with the technology. You have to learn from the top at this point. Class 1 has nothing to do. There's no overlap whatsoever.
I don't think anybody builds class 1 anymore. Yeah, no.
Well, I see it with some of the electronics that I open up a computer. I'm looking at hardware that I get, even for a high-end gaming laptop or something, and I just say, this is not how I would have designed this.
There's a trade-off then, and there's a trade-off between quality that you're bringing to market and what is good enough to sell your product. There's, on the commercial side, it's all about the bottom line and how many widgets can we sell. Who cares if the quality is not there, because we're going to build 100,000 of them, and the target is, let's just sell. We don't have to worry about, or it's not a priority for us to worry about, if this product fails after 2 years or 3 years. We want that to happen because we want them to buy another one, another widget. But of course, it's different when you think about high-end stuff or class 3 type stuff, whether it's mil-aero, automobile, medical. Life dependency or importance of use is key. So you're on point, and especially regarding the skills gap and the age difference. I'm 55 years old, and I'm a baby of bunch within the circle I run with. And you go to any trade show, and the majority of people there are gray hair, older, mid 60s. If not, some of the lecturers out, like some of the top guns or the icons that are still bringing it. They're in their 80s and still on stage, a little slower, but their quality of content that they're sharing is extremely valuable, but we don't have enough of them. And the skills gap is getting worse and worse. And like you said, there are no entry jobs anymore. You look right now, there are tons of PCB jobs available, but everyone wants 10, 15 years. You want a whole list of things that you need to be able to do. And coming out of college, you're not even remotely close to doing any of that stuff, much less, like, I love the fact that you mentioned knowing the right tool. Don't get me wrong, a lot of these colleges and universities today, they have a tool that maybe a license that was given to them, and students are using however they're learning, whether it's YouTube or word of mouth. But the fact is to have a tool in the ecosystem, the right tool or the tools that are in these major corporations at this enterprise level, it's a whole nother ballgame. I mean, wielding, like you say, Xpedition. That's been my Excalibur for like 25 years. If I'm going to battle, that's the tool of my choice. Why? Because the functionality and what it allows me to do to be a better version of me as a designer, to meet the challenges for tomorrow, but to meet them today. And that's the key. So, since we're talking about tools, let me ask you, what is the role of EDA software in helping bridge that gap? How do you see that?
I think one of the most difficult things, even if you've got someone that understands all the concepts, is there's a learning curve for these tools. I don't think there's a simple engineering tool out there. It's just the nature of the beast. They take time to really understand and learn. And one of the things that I find with Xpedition is that I find new functionality as I go. And I've been doing this for a while. I'm not new to it. That's a huge, huge thing, is the continuing education portion of it. The EDA tool facilitating and making the things that you need to do accessible is massive. There's certain things that maybe one tool doesn't do and you have to do manually, and some of the automation built into it, the tool solving problems for you as you go. They're specific, and they seem small, but they're specific tools that I absolutely cannot do a dense DDR bus without. There's no possible way. We'd have to simulate every single line. That kind of time, that tool saving 18 hours of simulation, being able to set it up. The EDA tools that we have, especially Xpedition, just it decides whether or not you're going to be successful.
You're not the first engineer I've heard say this.
I've seen some of the things from some of the other tools, and I've seen some education things from some of what's out there, and I see recurring problems. Something that I have never dealt with is EMC, EMI issues. Some of that is because of how I design and the rules that I follow, but some of that's also the tool helping me out with things along the way, being able to set things up so that I don't ever have EMC issues. Because so I see discussions where they talk about they had to send it for testing and it failed and they had to redo it and they had to redo it. And I've never had that issue. I've never had something come back. I don't think that I could do that with some of the other tools. I think that learning the EDA tools that are available to us right now, being able to get into, especially with the new products that Siemens has with standard versus enterprise. And standard, there's some things I really like about standard, because especially with a lot of the other resources that you have, you don't have to have, it's perfect for a small organization. You don't have to have a librarian. You don't have to add all this extra overhead and extra work, because all that stuff is included. Being able to have components of hyperlinks and really high-end simulation built into it, learning all of this stuff, and then being able to expand. I can take someone new, get them learning on all of this, get them designing boards, actually making money, and then be able to scale up to enterprise when the time comes and start getting them into full hyperlinks and everything else. This is the stepping stone that I have needed for a while to be able to do what I want to do.
When you think about getting someone and getting them on a tool and getting up to speed, what is that learning curve? Fortunate what Siemens has done is paid attention to the need in the market and help bridge that gap, especially with our new UX or our new UI, with the user interface being more intuitive. So that way getting up to speed is just that much faster. And then, what we've done with AI and how to help bridge that gap. It's amazing, the evolution of the tool. I wish I had this powerful thing decades ago, but the technology just wasn't there yet at that time. It's amazing how we've evolved and what the tools today to be able to do, as you mentioned, those very, very high complex designs. But I think the key here is not just achieving success in those designs, but achieving it under project conditions, or what I call battle conditions, of the stress of the project, like you need it yesterday. At least elaborate a little bit on the schedule time. Like, what are the constraints that you're under to make it not just difficult technology-wise, but the stress of the project? I feel we got to say something about that.
That's the fun part. Solving problems immediately is kind of the bread and butter of what I end up doing. I have worked for 72 hours straight to redesign a board from scratch and get it out. When some of these time constraints are applied, and they could be, this is what we promised the customer, or we're behind, or there's a penalty for being late, or, hey, we need this technology out right now. It needs to be there for operational requirements. And we don't really get to know what the exact reason is. A lot of times, even the project manager may not know. So pushing for optimization of time, get it out working. It's one of the balances of, is this going to work? You can throw something together versus, is this the quality it needs to be as quickly as possible? There's some pretty heavy constraints on all of that pushes us. And that's where I rely on the tool also, is that being able to say, hey, I'm going to set this up, I'm going to throw it together, and then my design constraints are going to make sure that I don't get into trouble as I go, and my DFM rules and everything else that I need to do. Those constraints can be big. Usually I get things when it's an emergency. So we need this done, or this is broken, or it doesn't work. We need you to fix it, make it work. And so I've done a lot of that. And then just like you said, there's so many components to all of this. I've had some where the customer had an issue, the end user had an issue with power integrity on a previous board. So they were really pushing, we want all of this. And I spent 5 days in hyperlinks running all the voltages through, really run it through the PDN, doing all the math and saying, okay, this will do everything you need it to. We got plenty of room for everything. The time constraints on all that, though, it's that balance. It's the we need it to work, but we needed it yesterday. And so some of this can be extremely high stress. And then the other thing too is that printed circuit design, it's a bottleneck. You can have 10 engineers working on different parts of the schematic, put everything together, and now but the moment it gets to printed circuit design, it's kind of hard to have multiple people working on it at the same time, especially with a really complex board. You could be getting in each other's way. So you kind of end up running into on high-end designs. It's just you and you need to get it done. So there's always a push. It's feast or famine. We want it all done, or, hey, we don't have anything for you right now.
I've been there, done that for decades. I lived in that environment and I can almost taste it. You know what I'm talking about, especially that 72-hour push. But it's like you said, you got to bring it. It is what it is. It's the nature of the beast. Speaking of that, what are the most significant challenges do you encounter when educating PCB engineers? Are they specific hot topics that you're asked to do? You mentioned, power integrity. I find that typically it's just the purity of designing the board, the basic foundation. And I'm surprised how many people get that wrong. Even with complex senior people, complex designs or senior engineers, when you look at the issues they have, it's a very basic, like, what did you miss? Or why did you do this? This is a very simplistic reason. So give me your insights on this.
The major hurdles that I've run into is the amount of information you need to know. There is so much to printed circuit design. You need to know what can be manufactured. What are the rules? How expensive is it going to be to do it? We could do everything to the highest end, and now you've got $50,000 GPUs. And in a lot of the designs that I do, a single chip on the board is 60,000, and I have 4 of them. So we're talking $500,000 boards sometimes. We're talking boards 24 to 36 layers. When you throw in there mixed signal, when you're putting all this stuff on one board, understanding all of the concepts and being able to remember all of them and apply all of them all the time, that's where I keep seeing issues. As we get into really high speed, there's a lot of things that really need to be considered. And I've picked up boards where some of those rules just weren't followed. It wasn't necessarily sloppy work. They just maybe aren't aware of some of what we need to do to make these things work. You're talking about power delivery, which is huge. I've seen power delivery be an issue on a lot of boards. It seems to be a very common issue. I've seen signal integrity issues. That's the primary issue why boards with DDR come back, is signal integrity. Too much crosstalk or things mismatched or something like that. And now it says, I'm just not going to run. And you see that in some of the job postings, is that they want you to have DDR experience specifically. There's a good reason for that. Some of this is complex enough. And once you've seen it, then you can move forward. But there's just so much to learn. Like we were saying before, there needs to be mentorship, maybe like an apprentice style progression through this. That's what I want to do, is I want to be able to take younger guys, give them the opportunity to get into this. It's a fantastic career. Get them into this and oversee them until they're ready to run on their own. And even then be a consultant to say, hey, let me check this and kind of review. And it's that mentorship that I think is going to be the future. We're running into issues with talent disappearing all over the place. It's very difficult to get some of the vendors to get me what I ask for something even as simple as a stack up that works for what I need within my constraints. So there's some difficulties out there throughout the entire industry. It's not just PCB, but this is what I know. So this is what I'm trying to solve in the future. That's being able to be the resource to be able to get the massive amount of information, apply all the concepts all the time. I think that's the biggest thing. I think that the concepts that we apply that each individually are well within reach of any engineer out there, no issue. But putting them all together and then how they play together and how they interact with each other, and then being able to implement that in the physical world. I think that's the hard part.
This is why I love our profession as printed circuit engineers. I mean, it's you cross pollinate between mechanical domain with the physics, the electrical domain, electrical aspects, and then manufacturing. You have to think about manufacturing at the point of design. And then it's even, with the advent of COVID is supply chain resilience. Can you design for resilience? How do you bring that intelligence to the board and your decisions that you make and you're choosing your parts and what you're doing? So there's a lot to it. Now you think about the complexity of what you need to do when you're setting up constraints, which means that you're locking in your stack up and your rules that help guide you and it's correct by construction. You don't do that without close collaboration with your supplier, especially if you're doing something very complex, as you mentioned, the typical arena that you're in. When you're doing things really complex, you've got to work closely with your suppliers to dial in the foundation of your board, which is your stack up. Don't even get me started with library parts and building library parts that are made, or designed for manufacturability. When you think about mass production and what you're doing, and yeah, it's a lot that you have to absorb, and it's a lot you've got to bring to the table and understand what you're doing at the point of design. It really resonates in how this is happening or how we're evolving, and this is why that gap is getting bigger and bigger and bigger in what we're doing. So let me ask you, we talked about the skills gap and we talked about the tools, but let's go even one step further now. And what are your thoughts on the evolution, of the tools, especially, the thoughts on AI within the EDA tools and how AI is going to affect PCB engineering roles and the evolution of how we're going to use AI to bring engineers to market or bring them up to speed, especially, we're seeing the lack of academia, cultivating printed circuit engineers to be able to hit the ground running. And then, what are your thoughts on it? Do you embrace AI? What is your take on that?
I've seen a couple startups that tried to implement AI does everything. Understanding how AI works, that's just it's never going to be a thing. There's not enough good data to feed it for it to reproduce or create things. I think it'd be fantastic for class 1 boards, maybe some class 2 boards, but when it comes to what I do, you're never going to replace the engineer. However, having the tool be able to anticipate what it is that I need, what comes next, learning my workflow, recognize what it is that I'm trying to do, and have it be able to say, that might be an issue. Maybe you don't want to do it that way. I think there's a lot of applications for AI in this space. I think it does facilitate bringing up new people because, like I said, there's so much to know and so much to learn in PCB to be successful at the high end that trying to teach all of that, you're talking 5 or 6 years of full-time experience to be able to apply everything all the time. And if you have AI that can maybe prompt you, say, hey, maybe this isn't good, what you've got going on here, and then optimize some of the things. Automation has been huge in this space, custom scripts with different organizations. And the reason why is because it streamlines some things that take a long time. And if you're doing repetitive things, that's the perfect application for AI at that point, is when you're doing repetitive things and it says, hey, last time you did this, you did this. Maybe even prompt you down the line of, I'm doing my drawings. What notes do you want? Well, here's my fab notes that I need for this specific board. And then what's the application? What's this? What are your constraints? And have it say, okay, we're going to put all this together. I see application for AI in almost every aspect of utilizing the tools. So the more that gets expanded in the right ways, I think the more it's going to facilitate newer people coming into the space. Something as simple as I've got documents and checklists for new guys of this is all of the, and it gets into, it's massive. The documents that I have, the how to do this, even something as simple as, hey, we're going to send this to manufacturing, give us all our outputs. That can be complex. And AI can then say, well, this is the workflow you did the last 7 times you did it. Let's do that again. And it can ask you with a wizard style, step you through it and check everything. But as of right now, you need to know what you need, which files you need, which outputs you need, and who they need to go to build your full fab package. And something as simple as that, AI is great for that, because I can't tell you how many, even today, I still have to go back depending on my customer and check my checklist. Do I have everything here?
Yeah, I mean, it's actually using the checklist. Don't just check it just for the sake of checking it. Actually use it for what it's for. I mean, from your background, you've got to walk through the checklist. That's what it's there for. Its purpose is to make sure you fulfilled all the requirements, all the gaps, processes. Follow the process. Follow the process. Yeah. We got one more question before we finish it up. And so I want to talk to you about, with the current trends in talent gap, how do you think the gap will be closed? Talk about mentorship and your passion for help cultivating the next generation of engineers. How do you see this gap being closed?
I think it's going to take investment. That's something that I'm contemplating pushing for in the future. Grants to facilitate some of this, maybe pushing some of academia to at least have an option available that will allow students coming out to get exposure to all of these things, get exposure to the tools. Xpedition Standard is the perfect tool to give to students doing their senior design or their capstone projects and say, hey, make something, and then have it produced and actually build a product in the real world versus something that just checks the box for the academic program. I think it's going to take some investment, though. That's the interesting thing, is that I see Siemens putting in the investment. They're pushing to get this out there, get it available, and get people learning. But I don't see it from academia. And I recognize, and like I said, I've spoken to, like at Soft Week, I've spoken to some of the people that make decisions, and they're recognizing that we are missing some talent in this country. And I think that is enough to possibly get some investment from that direction also, is say, hey, this is what's needed, make it happen. And as soon as that starts flowing, I don't see the legacy defense contractors investing currently, but I think what's going to end up happening also is that when the current crop that they have that have been there for a long time all start to retire, they're going to be in emergency mode, and suddenly they're going to want to invest. But being ahead of the curve, there's going to be a gap. It takes time to develop. You cannot just make a printed circuit designer. You can't just plop someone in a seat. Here's the tool, off they go. So you're talking a couple years before they're really ready to do high-end boards independently. And I think that's going to take investment ahead of time. And that's what I'm trying to work on right now is I'm trying to fill that gap so that when the emergency comes, the blow is softened as much as possible until the big money starts flowing.
I couldn't have said any better, Ant. How do you fill that gap? What are we doing respectively in seasoned veterans like yourself and myself and what we're doing and what we're trying to do to cultivate and do our part? I mean, I know Siemens is doing his part with micro-credentialing and all the other things that they're bringing to the table and partnering with universities. I'm part of a team that's cultivating the micro-credentialing activities, and it's a lot. I mean, Siemens is definitely doing its part in doing that, but it's just not fast enough. There's not enough engineers coming out of school ready to hit the ground running. And I'm still surprised to this day. Many don't realize that printed circuit engineering is a career path they can take. And the reason why is because most academia don't have, a degree in printed circuit engineering. It's either electrical or mechanical or systems or hardware. It's not a printed circuit engineer. That is, like you mentioned earlier, the bottleneck. That is the skill set that is highly sought after. It's just not there yet. That gap is going to continue to grow, but Siemens is definitely doing his part in helping bridge that gap with, what we're bringing to the table with our solutions.
That's what I'm looking at is Siemens can't fix an industry. They can do their part, but the industry needs to get on board with it to really make a difference.
Yeah, it's got to be a collective effort. And it's hard because everyone has their own agenda and their own bottom lines that they're looking at. Competitiveness, when you think about AI having to learn from other technologies to improve itself, well, who's going to be willing to share their technology or their IP and then share that with the world? No, they're not going to do that. So, well, let's see how things evolve. I think that's all we have time for today. Thank you, Tim, for sharing your insights and education and what you're doing and helping to bridge that gap and cultivate the next generation. To our audience, I want to continue to tune in. I'd like you to continue to tune in for more trends, challenges, and opportunities across the printed circuit industry.
Hopefully I get to see you again soon.
We'll have a follow-up conversation. Believe me, there's a lot of good content. And even, what the audience don't realize is that you and I were talking 20 minutes before this podcast even started. We should have just hit record then, because that was a lot of gold there too. Awesome. Well, thanks for joining, and audience, continue to follow us for challenges and opportunities across the printed circuit engineering industry.